We are on the thermodynamics. Now we talk about the work done. Before starting the first law of thermodynamics, let's talk about some useful notation. First we talk about the work done. In previous video we talk about open system, closed system, and the types of systems. So all these parts are used in the system and surrounding part. Okay. So when we talk about a work done, so simply the formula says force into displacement. That is force into displacement. Okay, for example, say this is dot product, both are vector product, so the both vectors dot product become force Fs, and cos of theta, which was the angle, theta is the angle between vectors both. Okay, so this is the formula. So meaning the work done, meaning, for example, it's our pen. Okay, this is a pen. So when I apply a force on it, it displaces little bit. So it displaces this, and apply force from this, the angle is this. So the work done is when we apply a force on a particle, so it displays some distance infinitesimally small, for example. So it is the it is says the work is done. If I do some work but nothing is changed, like in its displacement, it says to be work that is 0, and I some do work, and after my doing work is separate little bit, for example, is separate from this. So this is an example of say displayed some distance. So it is we seeing that work is done. Now we are in a thermodynamics. So we talk about a system surrounding. So this is the part of our chamber, and this is our piston. Okay, now this is the system, and here is the surrounding. We talk about surrounding, say surrounding source, and say system SYM using the time. Okay, so when, for example, you see you are like an example of you press the piston. Okay, you press the piston. So in this case the piston is going, so we see this, when you press the piston goes down. So in this case the surrounding get worked on it. You work on this, for example, this is our glass, and you apply a force like your thumb on this, or an example of like a balloon on it, and through push from outside. That is the external force you apply, P external. So we see that volume, this is our final volume Vi. This is our initial, sorry, this is the initial, this is final volume. We see that the energy is increase. Okay, and the surrounding doing work. Okay, when the surrounding is doing work, the system on work on system, that is work on system by surrounding, we say positive, since pressure is the force upon area. So that's why we use work done as pressure P external, and to dV, which is our volume change, and this is work. Say if the dW is the small work, then we say integration whole part, and the work done is now positive. Okay, work done positive, because in chemistry surrounding apply one force, that's why force apply on you, that's why using the positive. So this is the integration. If P external is positive, sorry, constant, then is out from this integration and become dV V1 to V2, and we get P external with a positive sign and delta V. Okay, integration means, for example, we have small amount of marbles, and we integrate this 10 marbles, integrate 2, and where from 1 to 10, it means we collect all the integrals, that is 10. This is the meaning of 10. Okay, from 1 to 5. Okay, it become 10. So it means from infinitesimally small, from small value to if we collect all the small values from 1 to 10, so summing up all, it's called summation. That is integration. We integrate from 0 to infinity. So means from lower part to bottom part we integrate. It is the meaning of integration. And dV limit from 0 to infinity, for example 0 to higher part. Okay, and dV is the small value if you take. Okay, or if, for example, case 2, when a work by system. So in that case our piston is here. Once again, our piston in that case is here. So if the work is done by system and finally the piston gets out from the initial position, so it says V initial now and this is the V final. So in that case the work by the system is work by your. So in that case, for example, you see when we punch on the water is forced back. So in that case we see that some hypothetical case using our own assumption that the water work on us. So that's an example of work is we see that we put on this gas, we see that in work on it sometimes after getting the push back on our hand. So this is an example push back. Okay, so in that case system do work on surrounding. So in that case when system do work on surrounding, it's surrounding, in that case work done is negative. Okay, so negative means our dw, say integration of w become negative of p external if it become a constant. So v1 to v2 dv become minus of p external into delta v. Example of it. Okay, or if p external in both case is not constant, so in this case work done become p external dv minus v1 to v2. We take minus because all times we also sometimes use the system by work. So in that case we use some using the in that case the variable work done is allowed. So in that case we using the it is now both are variables, so we solve by using the identities of summations. This is the called example of it. So I hope you understand. If you understand, please explain someone else, assuming that you have sat in the front of you. And now I do some I gave you some questions like in own example or always question this own thinking. Make a question make a question not make an example, make an example, because I in next video we do some example, we do some question, then we solve some question. If okay, make an example where you see the work done on the work done and today lecture. If you understand, like and subscribe.